Hello everyone, this is Braj and you are watching BKTechWorld. So in this video, I am going to talk about the different sorting algorithm and its implementation with its time complexity in a Java language. So I will start with the bubble sort. Okay, so I have taken an array with 4 elements 4, 3, 17 and 1. And bubble sort works on a principle that it will compare the adjacent element to adjacent element, and based on our requirement whether we want to sort it in a ascending order or descending order, the value gets swapped with each other. Okay, so here I am going to sort in a ascending order so that the lowest element, okay, lowest element is 1 will be at the 0th index and highest element 17 will be at the last index value. Okay, so let's start with the first iteration. So in the first iteration we will compare the first two index element. This is 0th index element, that is 4, and 1 index element, that is 3. As we are going to sort in ascending order, our lower value should be at the lower index and higher value should be at the higher index. So we see here that 3 is smaller than 4, so we will swap these two value and our resultant array will be 3, 4, 17 and 1. Okay, now in the second iteration we will check the next two adjacent element, that is 4 and 17. As 17 is already larger than 4, we are not going to swap these two value and we will move to the next two adjacent element, that is 17 and 1. While comparing 17 and 1, we found that higher index value, that is 1, it is in third index and 17 is an 2 index, second index. So the higher index element 1 is smaller than the lower index element. So we are going to swap these two value and our resultant array will become 3, 4, 1 and 17. The point of notice here is, like you see, after the first iteration the largest value of this array, that is 17, is at the last index. Okay, or we can say like it is at the right place. Okay, now we'll see the second iteration, second loop. So we will again compare from the 0th index up to the second last index now, not up to the last index, because last index is already occupied by the largest element of our array. Okay, so let's start by comparing again with the element, first two index element. And we found like 4 is already larger than 3. So we are not going to swap these two value and we will move to the next to element, next to index element. Okay, that is 1 and 2 index. At one index value is 4, at second index value is 1. Okay, so the second index value is smaller than the first index value, so we are going to swap these two value and our resultant array will be 3147. So our here the second iteration finishes and we found, like after the second iteration, the second largest value of this array, which is 4, occupies the right place, or we can say the second last index value. Okay, now in the next iteration we will compare only these two value, or we can say up to the third last index only. Now here we will compare 3 and 1. Okay, first two index value, and we found like 1 is smaller than 3 and we are going to swap these two values. So the resultant array will be 1, 3, 4, 17, which is a sorted array and sorted. Okay, let's jump to the programming. So here I have already created a Java class named bubble sort jump. Okay, and I'm going to first initiate the array with its value that we have seen in an example. 4, 3, 17 and 1. Okay, so let's sort it out. Let's create an sort array with bubble algorithm and we'll pass it array as an argument to this method. Okay, so first of all I will store the length of this array. Fine, so for first iteration we will do from 0 to n minus 1 index. Okay, sorry. Okay, so it will be the loop from the 0 to the last index of that array. Okay, and second iteration will be to compare the value. So let's see j. Okay, and j will be less than n minus I minus 1 j plus plus. Why I have taken like j is less than n minus I minus 1, because after the first iteration the largest element will already occupy the last index, so we are not going to again compare the value up to the last index. We are going to compare value up to the second last index, or in the third iteration up to the third last index, so it will be minus by the I. Okay, now we will compare this to value. Okay, so if the higher index's value is smaller than the lower index value, we are going to swap these two value, because we are going to sort in a ascending order. Okay, so I will swap it using one extra variable. Okay, j plus 1 and array of j plus 1, array of j and array of j will have them. Okay, so if the largest index value is lower than the smallest index value, then we are going to swap the value with each other. As you can see here in this example, okay, the higher index value is 1 and lower index value is 4. So we are swapping these two values. Okay, so that's about the tool loop. So the complexity will be big of n square. So whether the array is sorted or not sorted, or it is in a random manner, we are going to use this to loop, and we are going to iterate from 0 to n minus 1, which is the n value. So the complexity will be in any of the case, like in the worst case, best case, on average case, it will be big of n square. Okay, so let's print this value quickly and see our output. Less than n I plus plus array of I. Let's run this value. Now you see our value is in a sorted manner, 1 3 4 17. So that's all for this video, guys. In the next video I'm going to talk about the different other sorting algorithms. And if you like the content, don't forget to hit the like button and do subscribe to my channel for more such videos. Thank you.